All right, everybody, today is March 2nd. Today's topic is vertex in standard form. So for the warm-up, you're finding the vertex for each of these equations. You're putting them in your calculator or in Desmos. All right, so the first vertex for this equation is positive 2, negative 5. You will see that the other one is positive 2, negative 5. Now notice both of these equations are written differently, but they come up with the same vertex. We're going to talk about today why that is. So first off, there are two forms of a quadratic. You want to write all of this down. Vertex form is y equals a x minus h squared plus k. Whenever a quadratic is in this form, the vertex can be identified by just looking at the equation, where h and k is your vertex. Now here's the thing, the sign of your k is the exact same sign that goes into the vertex. However, the h, since it's in the parentheses, is going to be the opposite of what you think. Your x's lie to you. So if it's currently negative, then it becomes positive in the vertex. If it's currently positive in the equation, then it becomes negative in the vertex. Once you have your vertex, just like always, you can also then identify your axis of symmetry. You could even go further and identify your range and some of your other attributes as well. With standard form, on the other hand, that's when you have ax squared plus bx plus c. A is a coefficient, b is a coefficient, c is a constant. C is also the y-intercept in this form, and that right there, looking at the equation, is the only thing that you can identify, is C being the y-intercept. All the other stuff you have to graph to be able to find out what it is. All right, so vertex form. Vertex form, it's easy to find the vertex, like we said. I have, in this case, f of x equals x minus 3 squared plus 6. I see this in parentheses squared and then the plus 6. So my vertex is going to be positive 3, positive 6. My axis of symmetry is going to be x equals 3. All right, pause the video and now you try. All right, so on this first one, I see it is in vertex form, so I can go ahead and identify my vertex to be negative 5, negative 8, meaning my axis of symmetry is x equals negative 5. However, the second equation, well, it looks pretty easy if it was in vertex form, but the problem is it's not. So since it's in standard form, I am still going to graph it in the calculator. If, when I look at the calculator, I can identify the vertex, I'll just go ahead and write it. And I see it ends up being 0, negative 4. So my axis of symmetry is x equals 0. Again, you can look at the graph or the table to be able to identify that. All right, so now that we know what vertex and standard form are, a lot of times what's going to happen is you're going to be asked to write a equation in vertex form and convert it to standard form. Or you'll be given an equation in vertex form and told which of these equations is equivalent to this one, which basically means you need to convert that vertex form to standard form. The question is, how do you do that? You do that by going back to the lovely box that we all love so much. All right, so the reason why we do that is we have x minus 6 squared. With standard form, we don't want to keep the parentheses, so the way to get rid of them is to follow what it says. When I see squared, that tells me I'm doing x minus 6 times x minus 6. We should remember this from when we were multiplying polynomials, that this is what we do. So that gives me the answer of x squared minus 12x plus 36, and this is an equation, so you do need to write it as y equals that. If you don't have y equals, your answer will be partially wrong. You must have y equals to make it an equation. All right, let's continue on. Pause the video and you try this one. All right, so first thing I'm going to do here is multiply, because I see this squared. X plus 4 times x plus 4. I'm not going to deal with that plus 5 until after I'm done multiplying what's in the parentheses. So now I have x squared plus 8x plus 16, and I still have that plus 5. So combine like terms, and I get y equals x squared plus 8x plus 21. And there's my answer. So what about now? What do I do now? I see I have a 3 in front, and I see a plus 5 at the end. Well, we're still going to do the same thing. I'm going to deal with the parentheses first. This part first, my squared, my exponent. That is the first thing that I deal with. So I'm multiplying 2x plus 1 times 2x plus 1 to give me 4x squared plus 2x plus 2x plus 1. So now I have 3 times 4x squared plus 4x plus 1. Notice that I left that still in the parentheses because the 2x plus 1 squared had a coefficient. Previously, we did not have a coefficient, but this time we did. So now we have to distribute that coefficient to everything inside the parentheses. So you get 12x squared plus 12x plus 3 plus 5. Notice I didn't have the parentheses anymore because now I'm going to add 3 and 5. Y equals 12x squared plus 12x plus 8. And now I have my final answer. All right, let's try one more. Again, pause the video, see if you can try this one on your own. All right, so first thing we should do is our box. Take care of that exponent first. 3x minus 4, 3x minus 4. 3x times 3x is 9x squared. That gives me 12x here and negative 12x here and positive 16. So I'm going to keep the parentheses because I do have a coefficient. 9x squared minus 12 plus 12, which is 24x plus 16. Then from there, I'm going to go ahead and start multiplying my coefficient, distributing it to everything inside the parentheses to get 18x squared, and then negative 48x, and then positive 32. Y equals. All right, guys, that's it.